Hello, Year 9. This will be my level 2 zipline CAD video. It'll be harder than level 1, but not as complex as level 3. We're going to start with a thing called an offset plane. Well, sorry, actually a plane at an angle. This allows us to do drawings that are not perpendicular to these three faces. So we're going to start by selecting one of either the red or the blue line. I'm going to select the blue line. Don't select the green one. And we're going to give this an angle of 100 degrees, like so. We have this plane here now. I'm going to do a sketch upon that plane. And as you can see, we're going to be slightly off axis. We're going to go to the middle. We're going to draw a circle and give it a diameter of 4. This is 4 millimeters if you have it set to centimeters. Here we go. We now have this, and we're going to extrude that out 2.5 meters that way. And we're going to make it symmetric, like so. Now, if we look from the front, we have our line that is not flat. Okay, now the next step we're going to do is we're going to create a sketch upon this plane. And we're going to start by drawing the surface that we want sliding upon this. Now, so to do this, I'm going to start with a line, and I'm going to go start here, and I'm going to go here, like this. And then I am going to go up just a little bit, along, and back down. So we have this rectangle, but it's slightly tilted, like this. To make it a perfect rectangle, we're going to use the perpendicular tool and make sure that all of our lines are perpendicular to each other, like so. We can dimension this line, dimension this line to the origin and give that a dimension of 2 millimeters, so it sits perfectly there. However, you can see there's a gap here and overlaps there. That's because we haven't set this angle to be quite right. We're going to start by drawing a line, making it a construction line, and drawing this along, making sure that this line is horizontal. It has a little symbol here, which means horizontal. And then we are going to dimension between this line and that line an angle of 10 degrees. And now that sits perfect. Amazing. I'm going to set this to have a length of 40 and a thickness of 2 for now. This will be our sliding surface. So this we are going to line up with the center there. So we're just going to go another construction line that goes from here to our origin, a line from our origin there to there. And we're just going to make sure that this line is vertical. Amazing. Okay. So now, I'm sure some of you will be wanting to use the material that has the least frictional resistance with this cable, which you will have to experiment to find out. So what we're going to do is we're going to make it 5 mils that way and symmetric. And we're going to have this sample that sits there. Now, this piece I'm going to create a component from. So we have a component of our 2 different bodies. Okay? Okay, so we're going to set up a joint. A joint is like a connection. I know we did them before. Don't worry, they're not that stressful. The first thing we're going to select with our joint is the center of our cable, and then we're going to pick the edge, this corner, so the center of this face that's right above it. Okay. That will bring it inside, but we can drag it down, I believe, 3 mils, so it sits on top. Okay, and we're going to make sure we've got motion slider selected. If we preview this, this will slide up and down our path, like so. Amazing. The next step is we can come to the next thing we're going to build is some sort of case to hold our sliding sample that we know is the sliding sample we want. So I'm going to start a sketch, and I'm going to click this face here, and we're going to capture position. So now we want to make sure that we draw some sort of box that's going to go like this, right? And what that will do is it will stop this from coming in or out. We can have this nice and held in place, but we can also swap out the sample we want. So if we get rid of those ugly lines I just drew as temporary, we're going to start with a projection of this box, okay? And we're going to have a line that comes off this, goes straight down, goes out, goes up, goes back along, back down, across, back. Don't make sure you don't hit these green ticks. These green ticks are super annoying. Can I turn them off? I can't remember how to turn it off. We're going to ignore it for now. I'm going to go like that. This is the shape we want. So we're just going to make sure that all of our lines we want to be vertical are vertical, like so. And we're going to start dimensioning it. I want to make sure that we have at least 1.5 millimeters there and 1.5 millimeters here. So I'm just going to click on that thing, and that will transfer the dimension over. So you can see that says fx 1.5. If I was to come in and change this to 2, it would change it on the other side, like so. Amazing. Okay, now I want to give this 4. I'm going to make this the same, like so. Okay, now if we look at our lines, these lines are black, but these lines are still blue. This slides out, and this slides around. So first thing I'm going to do is I'm going to get the collinear tool, which makes 2 lines the same, and we can do this. So now if we click one side, it drags the other side up. We're going to make sure that this here is at least a millimeter, so I'm going to go 0.5, and then I'm going to give it, oh, sorry, oh yeah, actually that's what I'll do, there to there as 2 millimeters. Now we have a small little box that will house our sample, which we can extrude out, like so. And now we're going to change this drawing to new component. I'm going to make this 20 mils long, like so. Now, this is not attached in any way, so we're going to start by creating a joint between these 2 parts. I have now discovered joining things as you go seems to be one of the best options. So I'm going to start by selecting, what face do I want to select? I want to select the center of this face here and line it up with the center of this face here. Now we're going to go motion. We're going to change this to this way, and I'm going to set limits on this. So I'm going to have a maximum and I'm going to have a minimum. I'm going to have this as 10 mils. So this will allow it to slide a little bit, and this as negative 10 mils. Amazing. So this piece slides there. This does slide on this piece, but they're still attached. In your real physical one, you can probably glue them together, but this looks pretty good for now. So this slides on our cable. Amazing. If we select our 2 pieces of our thing, we come here and we go center of mass, go OK. You can see that our center of mass is above our cable, which you don't want. You want it to have it below the cable. And we need to come up with a way of storing our coin. So the first thing I'm going to do is, as I'm sure you've all worked out, the only 2 forces that act upon our thing is the frictional force with our lovely sliding plate onto the cable, and the air resistance that you call it. So you want to have the minimum amount of air resistance as you possibly can. Anyone who's done any research will know the shape that has the most minimum air resistance is the insert what you know here. I'm going to do some drawings of what I think it could be. If you've done your own research, you'll know the shape you need to draw. Okay, so there was a little bit of a cut there. I'm sorry, I spoke poorly and just changed my mind on what I want to do. So, as you know, the only 2 forces that act upon this thing are the frictional force, which we get from this material onto our cable, and the aerodynamic force. So we're going to have some wings coming off the top here, but we want these to be as aerodynamic as possible. So we're going to create a sketch on this top piece, and we need to create some aerodynamic shapes. Now, as you've done your research, you'll know the most aerodynamic shape. I am going to do what I believe the most aerodynamic shape is, which is probably the spike. So we're going to start with my spike, which I'm going to draw like this. Like so. I'm going to make sure that these get nice and tangented, like so. And then that tangents to there. And we can see this is going to look pretty spiky, which is what we want. And I'm going to give this a dimension. So I'm going to give that a radius of 4. That sounds pretty good. And then this a length of, that seems fine too, 20-ish. Amazing. So now we have this lovely spiky bit that's going to come be super aerodynamic for us when you look at it from the front. I'm going to extend this 50 mils, like so. Boom. Ooh, okay, and so that's what I'm seeing right now. Now, as you can see, the center of mass is now below the wire, but it is off to the side, so this will fall off. So what we want to do is we're going to create a mirror, of the feature, and we're going to select this extrude we just did, mirror plane, as our lovely center plane, kept centered there, like that. And we've got our super aerodynamical spikes on the front. Okay, like so. Now, if we look back again, the center of gravity is perfectly centered. It seems to slide down. The only thing we need to add is some way of holding the coin. Now, if we've made this big enough, we might be able to make a slot in the back here for our coin to sit in. So let's just CAD the coin and make sure it'll fit. Create a new piece, and we'll just do it on this face. Let that load. Amazing. And we're going to draw a 50-cent coin. Now, a 50-cent coin is not a circle, it is a dodecahedron. I'm going to draw a dodecahedron, which is a 12-sided shape. So just have 12 to tab to swap to the number, and then type in 12. And here we have our shape. A 50-cent coin is 31 millimeters across. 31. Or 32, we'll go for that. Like that. Boom. That is our 50-cent coin. Finish sketch. We're going to extrude that out 2 millimeters thick, like so. And we are going to attempt to dump. Oh, sorry, this is its own body. Let's make that a component as well, and then we can move around. We need to work out where we want to put this. Okay, so I'm thinking we decide to put the coin kind of, I can move it to the right spot, inside this wing. Does that make sense? If this could sit like inside there, then we wouldn't get a super amount of drag because it's inside our lovely shape. Like so. Okay, to do this, I'm thinking we bring this out a bit, maybe fatten it up a little bit. I think we need to make it a bit, go backwards a little bit more, and then this will go well. So to edit our previous sketch, we're going to come here, edit, and I think we actually want this to be a little longer. So let's go, we had a coin is 31, so if we make it 40, boom, like so, and we have this connect up here, we still have that lovely shape. These wings stick out a bit to the back, that's okay. And now we look from the bottom. If we can get our coin there and bring that vertically, bring that down to this face, right? That could sit inside there and be super aerodynamic. So what we're going to do is we're going to put a hole here for it. The easiest way I can think to do that is to offset a plane to be inside here, and then do a sketch that looks like the coin and cut it out. So we can construct an offset plane with this one here. Make sure to capture position. We're going to go off our lovely center plane, and we're going to bring it out so it's in the middle, which is going to be there, 10 millimeters. Amazing. And we're going to do a sketch on that plane. Boom. So our sketch is kind of inside our piece, as we can see. Amazing. If we draw a circle here, that is dimensioned to be 33 millimeters in diameter, so it fits the coin. And we extrude that circle, finish sketch, extrude that circle, 2.5 millimeters, so it's bigger than the coin, and then go OK. Do we have a hole that we can stick a coin into? Yes, amazing. So we put it in there, but there's nothing stopping it falling out. So what we're going to do is we're going to add some way of retaining it. The easiest way I think to do that is to have a little sort of lip that it sits into. So what I'm going to do, yeah, we could sticky tape it in. You know what? I'm going to say we sticky tape it in. So to get it in the right spot, we're going to use a joint, and we're going to select the center of this circle and the center of that circle. And when, instead of having motion, we're going to change that to rigid. So that holds it quite nicely. Amazing. And we go, okay. Perfect. Okay, now we want to know where our center of mass is. Right now it's not on center, but that's because we're not accounting for the coin. So we're going to go inspect center of mass. We're going to choose our 3 parts, like so. Okay, and now we also want to assign the materials. So we're going to right click on component, physical material, bring open this tab. Now our coin is silver, so we're going to scroll through the metal tab here for silver. Here we are, and we're going to add that to the coin. And then I'm thinking we might be 3D printing this piece, so that will be a plastic. So I'm going to come look for plastic. Here we go. Amazing. And we 3D print in PLA. So we're going to scroll down, find PLA or PETG. Hopefully. Fine. Polylactic acid. Polylactic acid. Polylactic acid. You know what? We are going to call it PET. That's PETG. We're going to go with the PET, this one here. Boom. Amazing. And then for our super slopey surface, I don't know if anyone knows this, but Teflon is the smoothest thing. Is Teflon here? No. The other name is PA11, nylon. Sure, we'll go with that. Boom. Amazing. So this is what it would look like. Can I get it colored? I might color the part, otherwise it's super see-through and kind of hard to see. So we just click here, right click, and right click. Amazing. Appearance. We can give it a different appearance. So I might just go plastic and call it white. Is a nice white. This might be a nice white. Boom. Yeah. So that hasn't changed its physical properties. It's just changed its color. There we go. So here's our sliding carriage. Amazing. Okay. However, if we look at it right now, our center of gravity is super off to one side because the coin is much heavier than this. My way of accounting for it is I'm just going to extend this face out a little bit more. I don't quite know how much to extend it. Hopefully to center it. I'm going to maybe a little bit more. Um, or we could add a hole in it and add a little metal rod inside, which would also help. Let's try that. Let's do a sketch. Go here, add a hole, add a diameter. We'll go 5mm rod, an M5 bolt. Finish sketch. It's okay that it's blue because it doesn't really matter where it's going to go. We can extrude that, maybe that far. Okay. And then we can turn that sketch back on here, and we can extrude it again as a new component all the way up like so. Go OK. So we have this lovely new component. We're going to assign it a material, physical material, bring it out. We're going to go a steel bolt. Go back down, find metal, scroll until we get steel, stainless steel, steel. And we'll just go regular steel. Okay, amazing. Turn that around. Hide this. Now, inspect, center of mass, and we're going to make sure we select that piece, that piece, that piece, and our lovely new bolt. And then you go OK, and you can see our new center of gravity is pretty centered. I love that. That seems basically as good as we're going to get. As you can see, we're carrying a 50-cent coin. It's super streamlined because of our amazing curves, and we can decide what material to make this out of to give us the best chance of reducing friction. I'm just going to make sure I at least put this into our hole before I finish. So I'm just going to construct, I do a joint, sorry, joint that circle, the inside of this circle, and that's rigid, amazing. And we have our bottle. I hope that wasn't a long video. That one might have been quite long.